So hi and hello there, welcome to the new video of the course, and in this particular video we are going to study a new mini project, that is automatic street light controller or automated darkness controller. Okay, so at the end of this particular video you would be in the situation to understand that whenever the sun rises, then how the street light is in the off condition, and whenever the sun sets, then how the street light is going to be in the switch on condition on its own. Okay, so this is what we are going to learn in this particular session. So moving further, this is the block diagram of our project, that is a sensor, that is LDR sensor, then controlling system, that is a BJT which we are going to use as a switch, and then output which is been seen in a form of LED. Okay, and if you could remember, the block diagram is similar to what we had seen in the previous session, that is automatic brightness controller. So in case like when we saw the concept of the automatic brightness controller, okay, so the block diagram was same in this case as well, right? But the thing is that here we are making some minor change. So before moving to the automated darkness controller, let me move to the circuit design of the automatic brightness controller. Okay, so this is what we had designed in case of the automatic brightness controller, right? So over here the LDR sensor, it was above, that means it was connected to the VCC, right? And if this particular resistor, that is 50 kilo ohm, it was connected to ground and then to the LDR and to the base terminal of the BJT, right? Now moving to the automated brightness controller, automated darkness controller, we had just done a minor change over here. So if you could see very clearly what we had done, we had uh, uh, just interchange these two particular component. That means what we had connected this 50 kilo ohm resistor in between the base terminal of BJT and VCC, and this particular LDR sensor we had connected to ground and in between the base terminal, right? So we had just interchanged these two components. So let me just highlight this particular point over here, so whenever you will refer this PDF you should not get any doubt. So basically what I had done, I had interchanged these two components. So I had interchanged these two particular components, interchanged the components, right? Components. And now I'm just comparing this particular circuit with the block diagram. So as you can see, this is your sensor, that is LDR sensor. That means this particular thing, that is LDR sensor. So this is your sensor. Okay, then the controlling system is your BJT or bipolar junction transistor, right? So this is your controlling system, and the output is being seen in form of LED, right? So this is your output. Let me write over here, this is your output. Okay, so I hope you understood the block diagram, and obviously we had compared this particular block diagram with this particular circuit, and I hope that you also know the working of LDR sensor, at least a basic idea which we had seen in the previous session. But from my side I would also like to revise the concept of the LDR sensor one more time, okay, so that there won't be any doubt in your mind. Okay, whenever in the further video we are going to see we are going to analyze this particular circuit, right? At that particular time this LDR will play a very crucial role. So for that I'll just explain this particular thing once again. All right, so let's suppose this is the light source. For instance, we had considered this is your sunlight, okay, and we are blocking the sunlight. That means what, none of the light ray is reaching to this particular LDR sensor, okay, and when there isn't any light reaching to this particular LDR sensor, so basically this LDR sensor will act as if it is open circuited. So basically it will provide high resistance which would be in mega ohms, okay, and by the Ohm's law we know that if like V is equals to IR, and if R is high, okay, that means resistance is high, so your current would be almost equivalent to 0. Okay, that means what, when there isn't any light ray falling on this particular LDR sensor, it will act as an open circuit. So this is what we had concluded in the previous session, right? And in case 2, what we had done, we are passing this particular sunlight to this particular LDR sensor, and as this particular sunlight strikes this particular LDR sensor, so this particular resistance which was in mega ohms in the previous in the previous case, it will drop to few ohms, right? That means what? Your resistance is decreasing, and that's why by Ohm's law your current is increasing. So this is how the graph will look like. See over here, when there isn't any light incident on that particular LDR sensor, it will be in it will be in mega ohms. Okay, maybe 10 mega ohms, 1 mega ohm, it can be anything. Okay, but as soon as we provide certain light to that particular LDR sensor, it would be few ohms, maybe 100 ohms, 1000 ohms. Okay, it can be anything, but it would be in few ohms, right? So therefore the current would be high whenever the light is incident on the LDR sensor. Okay, so I hope you understood this particular concept. Okay, so now moving back to our project. Alright, so what we are done, we are just we are analyzing this particular circuit in two cases. So in case one, what we are doing, we are keeping this torch away from this particular LDR sensor, or basically we are not passing any light, or we are not making any light ray incident on this particular LDR sensor. Okay, so when your torch is in off condition, so we know that this particular LDR sensor will act as if it is open circuited, right? It will provide high resistance. Okay, so this particular LDR sensor will provide high resistance. So let me write over here, maybe I'll take this color. Yeah, so this LDR sensor will provide high resistance, right? High resistance, and acts as an open circuit, right? Open circuit. Okay, so what is going to happen? See over here. Oh, sorry. What is going to happen? As we had connected this as we had connected this particular resistor with VCC, so what is going to happen? There would be one current, small current IB flowing through this particular resistance, right? There would be one small current IB flowing through this particular resistor, right? It will flow in this particular direction. So your IB will flow in this particular direction. Okay, it will never ever flow in this particular direction. It will never ever flow in this particular direction. Why it will never ever flow in this particular direction? Because this particular sensor, it will provide high resistance, and as I told you in the very first course, current will always flow from that particular path which has low resistance, right? Since this particular LDR sensor is providing high resistance, so it will never ever flow in this particular path. It will prefer to go in this particular direction. So your IB will move in this particular direction, right? So let me erase this particular thing. Okay, so your IB will move in this particular direction, and then there would be some voltage drop across this particular transistor, plus minus VB, right? And then there would be some emitter current, okay, IE, right? And we all know what, if there would be some input current, then there would be some output current as well, that is IC. So your current IC will flow in this particular direction. So long story short, what I want to conclude is this. See over here, there would be some current IB flowing in this particular direction. So this is your current IB flowing in this particular direction. This will act as an open circuit, right? This will act as an open circuit. This will act as an open switch or an open circuit. Open circuit, right? And we all know that IC is beta times of IB. IC is beta times of IB, right? And there is some amount of input current or base current flowing through the base terminal of transistor, right? And therefore there would be some IC current as well. So what I can say over here, just a second, let me erase this particular thing. In this particular case, the current or the input current is maximum, so IB max. I will write over here IB as IB max, and therefore there would be some output current, that is IC max. Okay, so therefore there would be some output current IC max which will flow in this particular direction. Just a second, let me just take one VCC over here, plus VCC, right? And as you can see over here, in this particular case, there would be some voltage drop VBE. Okay, and this VBE, obviously this VBE would be greater than 0.7 volts. Okay, and since this VBE or the input voltage is greater than 0.7 volts, so therefore this transistor will act as a short circuit. So this particular transistor, see over here, this part, just a second, yeah, this particular part, it will act as a short circuit. Okay, so let me erase this. Okay, so over here, this particular thing, it will act as if it is short circuited. Short circuit. So BJT acts as a short circuit. BJT acts as a short circuit. Acts as a short circuit, right? And thus there would be maximum current IC flowing in this particular direction. So let me write over here. This would be the current IC flowing in this particular direction, right? And since IC flows from collector to emitter, that means what? It is flowing from VCC to ground. Okay, and we all know that IC is almost equivalent to I. There's hardly any difference. Okay, since this particular IC is flowing from VCC to ground, so obviously this LED is going to be on. It would be in on condition. So I'm taking just a random color. Okay, just for the explanation purpose. Okay, so just a second. Yeah, so this LED would be on. It would be in on condition. So let me write over here. I will take this one. Yeah, LED would be in on condition. So LED would be in on condition. LED is on. I will write. Okay. So the conclusion is this. That means what? See over here. In this particular condition, the LDR would be LDR acts as an open circuit, right? Acts as an open circuit. But over here the input current IB is maximum, and therefore the output current IC is also maximum. Okay, but input current IB is equivalent to IB max, right? IB is equivalent to IB max. Therefore output current IC is equivalent to IC max, right? And thus, due to these two reasons, what is going to happen? The transistor or the BJT acts as a closed switch. Okay, so let me write this particular reason in the next slide. Just a second, let me delete this particular part. Yeah, so therefore BJT acts as a closed switch, or in other words, what we can say, or it is operating in saturation region, right? Why? Because your current is high, or the input current is high in this particular scenario or in this particular condition, right? So let me just draw a rough diagram over here. That is the output characteristic of BJT. So this would be the output characteristic of BJT. This is your IC. Oh, sorry, this would be your VCE, right? Which would be VCC. This would be the maximum value, and this is your IC or IC max. IC max I will write, right? And we all know the DC load line, it is drawn between two maximum points. So and we'll just draw a rough DC load line. Yeah, so let's suppose this would be the maximum point for the output current, this would be the maximum point for the output voltage, right? And this is your DC load line, and as we had proven over here that this particular BJT transistor is acting in the saturation region for this particular condition when the torch is off. Okay, so this is how it will look like. So, oh sorry, just a second, I'm not good at drawing, so I will try my best to draw it properly. Yeah, something like this. So your BJT is operating in this particular region, so this is the saturation region. Okay, so what we can conclude over here, when torch is off, or basically light is in off condition. Okay, when light is in off condition, torch is off, I'll write torch is in off condition. When the torch is in off condition, okay, BJT acts as a closed switch, a closed switch. See, I'm writing it again and again so that you should understand this particular concept in depth, right? BJT acts as a closed switch, and therefore LED what? LED glows, or LED is in switch. LED is in on condition. LED is in on condition, or it glows. I hope you are able to understand my point. It glows up. Glows means what? It acts in the switch on condition. Okay, so LED is in on condition. So this is the most important concept you should be able to understand. Okay, I hope you understood this particular case, right? Now moving further, let me move to the next case. All right, so as you can see, what I am doing over here, I'm switching on this torch. Okay, and as I am switching on this torch, so this particular light rays, it is getting incident on this particular LDR sensor, right? And we all know that as soon as this particular light strikes this particular LDR sensor, this particular LDR sensor will act as a closed switch. Why? Because the resistance of this particular LDR sensor, it drops from mega ohms to few ohms, right? So over here what I can write is this. So the LDR acts as a, this particular LDR sensor acts as a closed switch, acts as a closed switch, okay, or it provides negligible resistance. I will write over here, just a second. I will move this particular point above because I don't have that enough space, right? So I will erase this particular part. Okay, let me move a little above. Okay, and it provides negligible resistance. Okay, so this is the most important concept that you should remember, right? So this was about LDR. Now we will see the working of this particular circuit, right, when the torch is in on condition. All right, so this is what we had seen. This particular part, it will act as a closed switch, and therefore what is going to happen? See over here, there would be one current flowing in this particular direction, right? So let's suppose the current is IB. Okay, as soon as this particular current reaches at this particular point, okay, IB reaches at this particular point, it sees that this particular part, it is providing negligible resistance, and this particular part, it is providing little high resistance as compared to this one, right? And as I told to you, current always follows that part which has almost zero resistance, or which has less resistance. So as you can see over here, the resistance is less, right, as compared to this particular part. So the IB, or the current which was flowing in this particular direction in the previous case, right, now it will flow in this particular direction. So your current IB will flow in this particular direction, and thus, or what I can write over here, just a second, one small mistake from my side. Let's suppose what I will do, I'll assume this current as just a second, let me just erase this particular thing. Okay, I'll just assume this current as I. Okay, forget that this is your base current, right? So therefore this current I will flow in this particular direction, right? See what I told you, current always flows from that path which has less resistance. So as you can see, rather than flowing in this particular direction, it will flow in this direction, right? And therefore the current IB would be 0. Just a second. Let's suppose this is a current I, and therefore the current I flowing in this particular direction, I mean IB, the current IB would be, or the base current IB would be 0 ampere, right? So this is the most important key point you should remember when the torch is in the on condition. So your IB, or the input current IB, is 0, and we all know that 0 microampere or 0 ampere you can take in general. Okay, and we all know that IC is beta times of IB, right? And since IB is 0, therefore your IC is also equivalent to 0 milliampere. So this is the most important key point you should remember. Okay, all right, so since IB is 0, so obviously there won't be any voltage drop across this particular base emitter junction. So your VBE is less than 0.7 volts, right? Your VB is less than 0.7 volts, and therefore your I is also 0, or I is almost equivalent to IC, right? And therefore it would be 0. You can also prove this particular case in this way. It's up to you. Okay, that's fine. That is not important. What is important is this. See over here, since your VBE is 0, that means input voltage is 0, so therefore this particular transistor will act as an open switch. Okay, I hope you are getting my point. See over here, this is acting as if it is open circuited, or it will act as an open switch, right? So I will write over here, this is acts as an open switch. So I will write over here, BJT acts as an open switch, right? Open switch. Okay, let me just it over here. This is your plus VCC, right? And as you can see over here, your IB is 0, and since your IB is 0, therefore the current flowing in this particular direction, it is also 0 milliampere. Okay, why? Because it is not able to reach up till the ground. And why it is not able to reach up till the ground? Because in between there is base emitter junction, and since base emitter junction, it is less than 0.7 volts. So, and why it is less than 0.7 volt? Because your IB is 0, and therefore your output current IC is 0. So long story short, what we can conclude over here is this. So I'm writing all of this point in detailed way because the devil is in the details. Okay, once if you understood this detailing part, the conceptual part, you would be able to design a lot of things, right? So the input current IB is 0, right? IB is 0. Therefore the therefore output current is also 0. Output current IC is also 0, right? And since both of this current is 0, okay, therefore, just a second, let me see how I frame this sentence. Yeah, therefore what? Therefore BJT acts as an open switch. BJT acts as an open switch, right? BJT acts as an open switch. So let me move further. Right, so this is the most important point. As BJT is acting as an open switch, right? As an open switch, therefore, sorry, that means it is operating in the cutoff mode. It is operating in cutoff region or in cutoff mode, right? In cutoff region, I will write, right? So let me just show this particular thing with the help of the output characteristic of BJT, right? So this is your output characteristic of BJT. This is the graph for VCE versus IC, right? So here you are supposed to draw the VCE, okay, VCE max, that is VCC, right? And here this is IC max, okay, IC max, that is maximum IC current. And let's suppose I'm drawing the load line in this way. Let's suppose this is your load line between the two maximum points, that is the maximum output current and maximum output voltage, right? So your BJT is operating in the cutoff mode, so it would be something like this. Just a second. Oh, sorry. So this would be, sorry, yeah, something like this, okay. And as you can see, the input current is almost 0. So this is your IC. Since your input current is 0, so therefore the output current is almost equal to 0. So BJT is operating in the cutoff mode. So let me see how I framed the sentence. Yeah, when the torch is okay. So when the torch is in the on condition, so when the torch is in on condition, right? When the torch is in on condition, when the torch is in on condition, just a second, yeah, BJT act as a open switch and therefore LED is in switch off condition. Okay, BJT acts as an open switch, right? BJT acts as an open switch and therefore the LED LED remains in off condition, right? Off condition. So as you can see over here, since your IC is 0, therefore it won't be able to move up till the ground, and thus this LED would be in off condition. I hope you are getting my point. Okay, so therefore this LED will not be able to glow, right? So just a second, just small mistake from my side. What I did is I didn't represented those two arrows. So always remember that whenever you are representing this LED, you should also represent this, or you should also show these particular two arrows, right? That means what? The LED is emitting light, right? These two arrows indicate that it is emitting light. Okay, so I hope you understood this particular concept in depth. So what we'll do, we'll again revise this particular concept. So alright, so the very first thing is this automatic straight light controller. Now I will show to you how exactly it will behave as a straight light controller, right? So this was the block diagram, sensor, controlling system, and the output LED, right? So we had compared this block diagram with this particular circuit. So this is our sensor, okay, this is the controlling system, and this is the output, and we had interchanged the components. Like in the previous session, what we had seen, the LDR sensor was connected over here and this 50 kilo ohm was connected over here. But in this particular session, for the automatic darkness controller or the automatic straight light controller, we had just interchanged these two particular components. Great. Okay, so moving further, what we saw is this: when the torch is in the off condition, so basically this LDR provides high resistance, okay, and it acts as an open circuit, right? So when it is acting as an open circuit, so there would be one current IB flowing in this particular direction, right? There would be one current IB flowing in this particular direction, and it will move from the base emitter junction to ground, right? And since there would be current IB which would be maximum, okay, flowing in this particular direction, so therefore the output current would also be maximum. And since there is some output current flowing in this particular loop, okay, which is able to move up till the ground potential, so therefore this LED is in the on condition, or LED would be able to glow. But the most important thing that we should be able to know is this: that means what? The BJT is operating in the saturation region. Why? Because it is acting as a closed switch. So this is the most important point we should be able to grasp, or we should be able to understand from this particular circuitry, right? Moving further, let's suppose if I'm switching on this particular torch, so obviously whenever the light strikes this particular LDR sensor, it will provide very less resistance, or the resistance of this particular LDR sensor drops from mega ohms to few ohms, right? Okay, so therefore it will act as a closed switch and it provides negligible resistance. Great. So moving further, what we can do over here, alright, so as you can see over here, as I told you, current always flows from that path which has less resistance. So let's suppose this is your current I flowing in this particular direction, and as soon as it will reach at this particular point, it will see that this particular base emitter junction, it is providing high resistance as compared to this particular path, right? So therefore it will prefer going in this particular direction, right? And due to this, what is going to happen? This particular BJT acts as an open switch. Why? Because the IB or the input current is 0, and as the input current is 0, so your output current is also 0, okay, and therefore the emitter current is also 0, which indicates that your input voltage VB, it is less than 0.7 volts, and therefore this BJT acts as an open switch. Okay, so this is what we should remember, this is what we should conclude in this particular case, that is, as BJT is acting as an open switch, that means it is operating in the cutoff region. So as you can see, this is the cutoff region. When the torch is in the on condition, BJT acts as an open switch and therefore the LED remains off. Okay, so now instead of torch, just replace this torch with sunlight. That means what? When sunlight, or basically when sun, like when sun does not rises, or basically it is when the sun is almost setting. So during sunset time or during night time, what I can say is that BJT acts as a closed switch, right? And during night time, that means what, torch is in off condition. So you can also consider this case as, just a second, so I'll just provide this particular point so that whenever you are referring this PDF, you should be able to understand this particular word. Torch, see over here, this particular case, that is torch is in off condition, right? So let me just highlight this particular part, and the torch is in off condition. Torch is in, oh sorry, torch is in off condition. Off condition, that means what, we are talking about night time. Okay, during night time or basically darkness. What we are talking about, we are talking about, just a second, night time or darkness, okay, or time after sunset. So after sunset, so we are talking about sunsetting time, or basically after 7 p.m. okay, so sunset, after sunset, I'll write over it, time after sunset, time after sunset, right? Sunset. So at night time, the LED is in the on condition. That means what, your street light would be in on condition. I hope you are able to consider my point, or I hope you are able to understand my point. Okay, so your LED would be in on condition. That means what, your street light would be in on condition, and that they will glow. Okay, as you can see over here, the LED is glowing when the light is not striking on this particular LDR sensor, right? Now, yeah, talking about this particular case, just a second, let me again highlight this particular point. Torch is in on condition. Torch is in on condition. That means what, when your sun is rising. So torch in on condition. Torch in on condition indicates that the time before sunset or daytime. So I will take different color. It indicates that we are talking about daytime, okay, or time between sunrise and sunset. So okay, so time between sunrise and sunset. Sunrise, maybe 6 a.m. or 7 a.m. to sunset, that is 7 p.m. to sunset, right? Sunset. So between this time interval, your LED remains off. That means what, your street light is going to be in off condition. It will never ever glow whenever there is some sunlight present on the, on your in your country or something like that, or in your area. The street light would be in off condition, and as soon as the sun sets, right, or during night time, what is going to happen? So during night time or during darkness, the street light is going to be in the on condition, right? So during night time, the street light would be in on condition. So this was the most important key point that you should remember, okay, or this was the most important conclusion that we had concluded in this particular video, and I hope that you really understood this particular part in depth. Okay, so now we'll straight away jump to the Proteus software, and we'll see the working of this particular circuit, right? So let me move to that particular Proteus software. Sorry, yeah. So as you can see over here, this is your LDR sensor, and I hope that you know how to take these particular components as we had seen in the previous session. Okay, so I'm not showing you this particular thing again and again, okay, so that we can save our time. So as you can see, just a second, let me move little above. Yeah, so as you can see over here, this is the LDR sensor, this is the torch, and this is the 50 kilo ohm resistor. This is the resistor, so that the like majority of the current should not pass through the LED. If majority of the current is flowing through the LED, this LED will burn out, right? So for that very purpose, we had connected this 500 ohms of resistor. This is your VCC, that is 5 volts, right? So now we'll run this particular circuit, and as you can see, just a second, yeah, as you can see, when the torch is in off condition, right, as you can see, the torch is off, okay, or it is far away from this particular LDR sensor, so your LED is glowing. I hope you are able to see. As you can see, the LED is able to glow, right? Just a second, let me move it a little down. Yeah, so the LED is able to glow, okay, so that means what, we are talking about this condition. Just a second, yeah, yeah, we are talking about this condition. So as you can see over here, this LDR provides high resistance, so therefore the current flow in this particular direction and output current flows in this direction, right? So therefore your LED is on condition. So this particular scenario, it indicates what? It indicates that your street light is in on condition. That means uh, we are talking about the darkness condition. We are talking about the condition after the sunset, or sorry, time after the sunset, right? That means night time. Okay, when there isn't any sunlight in your area or in your locality, right? Now what we'll do, we'll we'll slowly move this particular torch in this direction, and this torch would be in on condition. Alright, so as you can see, the torch is in on condition, and as we are moving this particular torch closer to this particular LDR sensor, so as you can see over here, as soon as the rays of this particular torch is hitting this LDR sensor, so this particular LED, it will remain off. So as you can see, it is in off condition, right? So yeah, we are talking about, that means what, we are talking about this condition. See over here, sorry, yeah, as you can see, when the torch is in on condition, the LED will not glow, okay, or it will, or basically your BJT will act as an open switch. That means what, we are talking about the time between sunrise and sunset. So during daytime, when your when the sun rays hit on this particular sensor, or hit this particular, or when the sun rays is incident on this particular LDR sensor, what is going to happen? The current will flow in this particular direction, okay, and thus this particular LED or this particular street light in general, we are talking, would be in off condition. And now I hope that you understood this particular concept in depth. Okay, so what I will do, I'll end this video, and after this video you would be able to see the exact working of this particular model. Okay,